So what steps are needed to conduct a goodness of fit test? Well, the first thing is the data needs to fit two important criteria. First, the data needs to come from a random sample, and secondly, the expected frequency for each category is 5 or more, and the categories will make more sense later. But if we were doing birth months or cans of soda, we need at least 5 or more. So when it comes to stating the null and alternate hypothesis, there's a very specific format. When it comes to H0, the format is there is no difference from the claimed distribution. Now, it might be something like the distribution is normal or uniform, or however it's worded. And then when it comes to H1, the alternate hypothesis, there is a difference from the claimed distribution. So maybe the distribution is not normal, is not uniform. And just one value needs to be different, not all the values. So for example, if H1 said everybody is 20 years old, then the null hypothesis, the alternative hypothesis would read something like, at least one person is not 20 years old. So we don't need everybody to be a different age. That's not the exact opposite of all being the same age. We just need one person to be a different age, and therefore not everyone is 20, and we have our alternate hypothesis. And if you think about it, that's what we've been doing all along. So if you notice in chapter 8, we would have something like the average equals 20, the average doesn't equal 20. So it equals something and it's not equal to something. Chapter 9, one population equals another, one population does not equal another, but it doesn't mean they're all different. And so in chapter 11, we're going to be using equal and unequal or not equal, but it's going to be sentences in words. In terms of finding our critical value, we're going to use the chi-squared table. And like before, degrees of freedom will be n minus 1. But something super important to note as to what n is. N is the number of categories, not how many data points were obtained. So like in terms of soda, we might look at 50 cans of soda, but there were only 3 categories, Coke, Diet Coke, and Sprite. Same goes with birthdays. So these data points are going to be what we observed, the 50 cans of soda that were most recently purchased. But N is the 3 categories of soda. Also, when testing, it's always going to be a right-tailed test. Even though H1 is not equal to, and it feels like it's a two-tailed test, with goodness of fit, we only use a right-tailed test. So that means do not divide alpha by 2, even though the claim feels like a equal and not equal two-tailed test. And so next we need to talk about the formula for the test statistic. And as you can see here, we've got the formula laid out where you should be familiar with the parts. The summation symbol means that we're going to be adding various things. Observed is what happened, and this will always be a whole number, and we'll talk about that again below. We're going to subtract from that the expected value. This is what should happen if H0 was true. And this one could be a decimal value because what happens or could happen doesn't always have to be a whole number. Think about like an average isn't always a whole number, even though it could be about whole number information. And so a shorter way to write this is that we're using O for observed and we're using E for expected. And instead of having each one divided by the expected, really you could add up everything first. And if you have the same denominator, you could wait until the end. But you'll see that isn't the case on every problem. So what you'll do is subtract the expected value from the observed and then square that subtraction. I'm just putting it again into words so the key pieces are understood. And then the subtraction is divided by the expected value unless a case every expected value is different for each of the categories. And of course, in the end, then we're going to add everything up. I already said it above, but the observed values will always be whole numbers as a reminder, but the expected values can be decimal numbers. And in the case of a decimal number, use at least 3 digits. I generally say to use 5, but this is a pretty long process, and if you're doing it by hand, it turns out 3 digits will be enough.